Okay, first of all, good morning to everyone. Am I audible to all of you? Very few students joined today. Near about 8 students only. Okay, in the last session, we seen about the ocean thermal energy. So I just want to revise that point again. Um, so I just want answers from you, your side only. So who will tell me that how ocean thermal energy is created? So what is the reason behind that? How ocean energy is created? Vaishnavi, can you tell me? Vaishnavi Dhole. We spent near about 2 hours for that point. So who will tell me about how ocean thermal energy is created? So what is the role of solar energy in that? So anyone from you, can you just tell me whatever the points that you heard in the last session or that you understood in the last session? So after that revision, we will move towards the forward, towards the next point. What is the reason behind the or how heat energy is created at the surface of the ocean? Today we are not going to conduct a practical. That practical session is converted into the theory session. Vaishnavi, Kishori, Amruta, Dipali. Anyone from you? Okay. I don't know why do you all are not telling answers, but heat energy is obtained to the surface of the ocean from the solar radiations that are falling on the surface of the ocean. Because of that, water is getting heated or warm water is available on the surface of the ocean. So by utilizing that heated energy and the cold water that is available, deep inside in the ocean. By utilizing what type of the water, we are converting the electrical energy, heat energy into the electrical energy. So the next type of this part is tidal energy. So what is mean by tidal energy? So can anyone having idea about the tidal energy, or what is mean by tides? Tides means what? Or we can call it as also ocean waves. What is mean by waves, tides in your language? Can you tell answers in your language, in your own way? Anything, whatever you know. First of all, tell me, am I audible to all of you? No one is muted themselves. I'm just talking. Even I also don't know is my voice coming to you or not. No one is responding. Okay, so tidal energy is nothing but what the tides are the rise and fall of sea levels caused by the combined effects of the gravitational forces exerted by the moon and the sun and the rotation of the earth. That means because of the geographical changes. So tides are nothing but what? It is the ocean waves. Tides are nothing but what? The ocean waves that are rising or falling, that are continuously rising or falling depending on the geographical changes. So which type of the geographical changes? Generally tides are changing based on the lunar phases. So lunar phases are nothing but what? The changes in the moon or celestial bodies. So celestial bodies are nothing but what? आकाशामध्ये जे काही चंद्र वगैरे आहेत तर त्याच्या व्हॅरिएशन्स नुसार जे टाइड्स आहेत त्याचे व्हॅरिएशन्स होतात. So tides are the rise and fall of the sea levels caused by the combined effects of the gravitational forces. So which geographical factors are affecting on the tides? Gravitational force, moon, size of the moon, that means the phases of the moon, and the sun and the rotation of the earth. These factors are affecting on the rising and falling of the tides. So this is about the tides. So some shorelines means what? किनाऱ्यालगतच्या भागामध्ये. Shorelines are nothing but what? किनाऱ्यालगतच्या भागामध्ये. So some shorelines experience almost two equal high tides. That means in a day there may be two equal high tides, or there may be two low tides in each day. So these tides are called as semidural tides. That means in a one day they are experiencing two equal high tides. High tides are nothing but what? The size of that high tides is water available or wave size is high, and two low tides in each day. So that tides are called as the semidural tides. So some locations experience only one high tide and only one low tide each day. That means depending on the location or depending on the geographical changes, these tides are going to form. That means the depending on the geographical changes, the size and size and number of tides are going to change. So these factors are depending on what? Force exerted by the moon or gravitational force, size of the moon, sun, and the rotation of the earth. So these geographical factors are going to affect on the size of the tides. सम शोअरलाईन्स म्हणजे काही किनाऱ्यालगतच्या भागामध्ये दिवसातून 2 वेळा हाय टाइड्स येतात आणि 2 वेळा कमी टाइड्स येतात. म्हणजे लो टाइड्स येतात, म्हणजे शॉर्ट टाइड्स येतात. तर त्या टाइड्सला काय म्हणतात, सेमी ड्युरल टाइड्स असं बोललं जातं. सो सम लोकेशन्स एक्सपिरियन्स ओनली वन हाय टाइड अँड ओनली वन low tide each day, called a dural tide. So some locations experience difference. So which that difference is, instead of 2 high tides or 2 low tides, they experience only 1 high tide and only 1 low tide. So this type of the tides are called as the dural tides. So apart from these two types, there is one more type, that is some locations experience 2 uneven tides a day. Uneven means what? The size, there may be high tide or low tide. So that size of the tide is not fixed. Uneven tides a day, or sometimes one high or one low each day. So it is not fixed. There may be some two high tides in a day, two low tides in a day. There may be one high tide, one low tide in a day, or there may be mixed type of the tides. So these tides are called as the mixed tides. So we just seen what is mean by tides. So which factors are going to affect on the tides, and what are the types of the tides. So in up till now we seen about the semi-dural tides, dural tides, and the mixed tides. So who will tell me that semi-dural tides? So I am expecting answer from your side. Just try to tell your answers. Anyone from you? Tides is nothing but what? It is the rise and fall of the sea levels caused by the combined effects of the gravitational force. So that gravitational force is created by the moon and the sun and the rotation of the earth. So because of the geographical changes, the size of the tides or rise and fall of the tides is going to change. So semi-dural tides means what? Which type of the tides are they? In each day, some shorelines experience 2 equal high tides and 2 equal low tides. So that experience or that tides are called as the semi-dural tides. So instead of 2, if there is a 1 high tide and 1 low tide, so at such cases are called as the dural tides. So what is mean by mixed tides? Mixed tides. Mixed tides means what? Someone try to tell your answers, or at least try to tell your opinion also. If you are not getting, if you are not understanding anything, whatever you want, but just try to unmute yourself. Otherwise, your attendance will not be recorded. Already there are only 8 participants in this meeting. So even if there is low attendance, no one is trying to speak. At least just try to express your opinions if you are not getting my point. Okay. I hope you understood this point. Just try to tell that understood or not. Are you getting this point? No one is responding. So in the just we seen about the types of the tides. In that we seen three types. So which were there? So semidural tide, dural tides, and mixed tides. So semidural tides is nothing but what? In each day, some shorelines experience two equal high tides. That means the size of that two tides is high, and two tides low in each day. So that areas are called that tides are called semidural tides. So some locations experience only one high tide and only one low tide. So that tides are called as the dural tides. So third type is the mixed tide. So in the mixed type, the tide size or there may be one low, one high. There may be both high, both low. So such type of the tides are called as the mixed tides. So next type is the according to the height of the tide. So next type of the classification is according to the height of the tide. So in that height of the tide, there are two classifications. So in that two classification, high tide and low tide, there are two types. So high tide means what? When the sea water reaches its greatest height within the tide cycle. That means when there is a tide cycle, so the sea water reaches its greatest height. That means the water availability in that tide is highest. So that tide is called as the high tide. When the sea water reaches its lowest height within the tide cycle, so that period is called that tide is called as the low tide. That means the height of the sea water is getting low in the low tide, and when the high tide is there, so the height of the sea water is highest or greatest. So that tide is called as the high tide. So are you understood this point? Shall I move towards the next point? Shall I move towards the next point? Okay, listen once again. In the classification of according to the height of the tide, there are again two sub classifications. In two classification, there are two types: high tide and low tide. So in case of the high tide, the sea water reaches its highest height. That means it's the greatest height or highest height within the tide cycle. When there is a tide cycle, the sea water reaches highest height. So that tide is called as the high tide. And when there is a low tide, that means when the sea water reaches its lowest height, that means there are so many tides throughout the day. So in that tide, two classification are done. That means the highest tide. Throughout the day, there are so many tides. In that, when the water reaches highest position, then that tide is called as the high tide. And when the water that tide reaches lowest sea water height, so that tide is called as the low tide. So the next classification is depending on the or according to the lunar phase. So lunar phase is nothing but what the stages of the moon, depending on the stages of the moon. So these tides are depending on the stages of the moon. So in that first type is the spring tide. So spring tides. So during the full moon or new moon phases, when there is a full moon or new moon, at such phases, the moon and the sun are aligned and their effects are combined. That means due to the effects of the sun and moon, there is some gravitational force experienced. So because of that gravitational force, spring tides are created. So spring tide is a classification of in the lunar phase tides. So on the tide tables, we can see high tidal coefficient of the tides when both celestial bodies are aligned. Celestial bodies are nothing but what? आकाशामध्ये जे काही चंद्र तारे आहेत त्याच्या ज्या चंद्र आणि सन आहेत दोन्ही एका अलाइन होतात तेव्हा तेव्हाचे जे टाइड्स असतात त्याला स्प्रिंग टाइड्स असं बोललं जातं. So this tides occurs when there is a full moon or new moon phase. So during this period, spring tides are formed. So it is proven that there is an increase in the activity of fish during the spring tides. When there is a spring tides, fishing activity is more. That means the fishes available inside the tides are more, and above all, if this coincide with sunrise or sunset, and these are the most propitious days for fishing. That means there are when there is a spring tides, these days are good for the fishing purposes. Okay, so again, I just want to ask you, what is meant by high tide and low tide, and how spring tides are created, when spring tides are created? So who will tell me the answers of these questions? Okay, who will tell me the answers of these questions? High tide means what? Low tide means what? Just we seen. When we are calling particular tide is high tide. Okay, anyone from you? Okay, just listen once again. High tide is the form when the sea water reaches its greatest height within the tide cycle. When throughout the day, there are so many tide cycles are formed. So during that tide cycles, when the sea water reaches its highest position, that means the greatest position. So that period is called as the high tide. And when during the tide cycles, that means the throughout the day, in each day, there are so many tides are formed. So in that tides period, so whenever the sea water reaches its lowest height, that tide is called as the low tide. So the next classification is according to the lunar phase. Lunar phase is nothing but what the state of the moon. That there are so many states: full moon, half moon, etc. So depending on that, spring tides are created. So spring tides are created when there is a full moon or new moon phase. So at this phase, spring tides are created, and there is a great time for the fishing during this spring tides period, because there is a coincidence of the sunrise and sunset. They are aligned to each other. So this is the great time for the fishing purposes. So in this next type of the tides is the nip tides. After spring tide, in case of the lunar phases, after spring tides, there is a classification called as the nip tides. So nip tides, NEAP, nip tides. So nip tides are created during the waxing or waning moons. Waxing or waning moons means what? There is a reduction in the size of the moon size. So on that period, the nip tides are created. So there is some geographical changes during this period, and because of these periods, the fishes available in the tides are low. That means there is a small scope or very low scope for the fishing purposes. So the movement on the seabed tends to be less, and this normally results in that days less propitious for fishing than days with the spring tides. As compared to the spring tides days, there is a low fishes available inside the nip tides in case of the nip tides. So in this image you can see here is the nip tides, here is the spring tides. So nip tides are occurred when quarter phase is there. That means there is a if there is full moon is not available, so at such cases nip tides are formed, and when there is a full moon or new moon, at such cases spring tides are formed. So there is a more scope for fishing in case of this spring tides only. Okay, I hope you all understood these points. If anyone not getting the points, you just try to tell me. I will repeat that points again. But you should answer for me. Is anyone having query regarding these points? Is anyone having query? So just listen once again. We seen in this session, first what is meant by tides. After that, um, types of the tides. So in that we seen semi-dural tides, dural tides, mixed tides. Then next classification is according to the height of the tide. In that we seen two types again, high tide, low tide. And third one is according to the lunar phase. So according to the lunar phase, how many tides we seen? Again two classification we seen, that is spring tide and the nip tides. So anyone from you can tell me any one type of the classification that we seen till now. Just try to tell your answers. If you are not speaking, I will not mark your attendance. Who will tell me any classification? Any classification according to the lunar phase, according to the any type, according to the height of the tide, according to the tides created. Just try to explore yourself. Okay, I hope you all understood this point. So we will move towards the next point. So the next point is the generation of tidal energy. So how we are creating the electricity by utilizing the tidal energy. So that we are going to see in this point. So we all know the tidal power is taken from the Earth's ocean tides. That means the whatever there may be ocean. So because of the gravitational forces that are going to exerted or that are going to generated, depending on that the size and size of the formation of the tides is depending on that gravitational force or celestial bodies. So by utilizing that energy we can generate electricity. So how we can generate electricity? We can place the various types of the turbines. So depending on the classification, so the depending on the application, how much of the electricity is going to generate, or depending on the plant, so proper turbine should be selected at such cases, and that turbine should be placed. So again there are types. So in the plants, so there are types of the tidal power plants. So depending on the which type of the plants that is going to install, so depending on that turbine is proper turbine is selected, so that wave energy or the water pressure that we are getting from the tidals or tides, that pressure is used to generate the electricity or to rotate or to spin the turbine. So here there are so many gravitational changes in the earth's ocean tides. So because of that forces, periodic variations in the gravitational attraction are going to happen. So these forces create corresponding motions of currents in the world's ocean. That means that because of this process there is a variation in the tides. So due to the strong attraction to the oceans, a bulge in the water level is created. So due to the strong attraction to the ocean, that means that because of the gravitational force, a bulge in the water level is created. A bulge means what? Bulge means what exactly? Bulge means what? फुग्यासारखा आकार तयार होणे म्हणजे टाइडची वॉटर हाईट हाय होणे. So that is called as the bulge. So that bulge is created in the water level, and when the sea is raised, so when the sea level is raised, water from the middle of the ocean is forced to move towards the shoreline. Whenever we all know, whenever everything is going from the high potential to the low potential, whenever bulge is created in the middle of the ocean, bulge is means what? फुगवट्यासारखा आकार तयार होणे. So whenever that bulge is created in the middle of the ocean, that so that increases the sea level, water sea level. So that sea level of water is increased, and that is going to force or move towards the shorelines. Shorelines are nothing but what, the किनाऱ्याजवळ, म्हणजे किनाऱ्याजवळ त्याचे जे waves आहेत ते फॉर्म होत जातात. So this occurrence takes place in an unfailing manner. That means this is the continuous process. That means these occurrences are continuous due to the consistent pattern of the moon's orbit around the earth. Because of the moon's changes, that is rotation of the earth, these changes are continuously going to happen, and the magnitude and the character of this motion reflects the changing position of the moon and sun related to the earth. That means because of these variations, the tides are changing continuously, and geographical changes are also continuously going to happen. So now I hope you all understood this point also. If you are not getting, just try to tell me you are not getting. If you are not getting, just try to tell. Okay. So in the generating methods, first step is the tidal stream generator. So in case of the tidal stream generator, there is a this type of the generators make use of the kinetic energy. That is there is a water continuously moving inside the ocean. So because of that reason, there is a mechanical force created inside that tides. So that by utilizing that mechanical force or kinetic force, the power is generated. So how that power is generated? There is a turbine that is placed inside the water, that is placed at the ground of the inside the water. So whenever that tides are coming towards the turbine, because of that pressure, that turbine is getting rotated, or that turbine is getting spin. So these turbines are classified again depending on the structure. There may be horizontal, vertical, open, or ducted are the types of the turbines, and that turbines are placed at the bottom of the water column, so that there can be mechanically fixed in a well manner, and they can hold the maximum amount of the pressure that we are getting from the waves of the ocean. So I will just share you one video. regarding that, so you can actually understand how that turbine works.
BD Energy Korea's tidal current power generator is anchored, which was transported to the installation spot after it was built at a shipyard. Then, using ballast tanks, the power generator is submerged so that it produces electricity while it is moored underwater.
So this is fixed in at the bottom of the water. That means inside the ocean, at the bottom of the water, the structure like this is placed.
The blades, which are designed with BD Energy Korea's patented technologies, smoothly open and close according to the flow of water and acquire rotational force with minimum resistance.
So according to so in this case, according to the pressure that we are getting from the tides or from the water, so this turbine starts rotating.
And by increasing the diameter of the rotating structure, it acquires the same acceleration effect without the use of a separate accelerator. To overcome the weight limitations from the increased size of the rotating structure is designed to be made of buoyant parts and to rotate while floating on the filled liquid. The extension axis between submersible buoyant structures serves as the support beam for rotation. Built using a truss structure, outside the extension axis between submersible buoyant structures, bearings are connected. And outside the bearings, the central axis of rotating structure, which consists of a truss structure, is connected. On the central axis of rotating structure, two blade parts and the rotating structure made of buoyant parts are connected into a single structure, and electricity is generated through the interaction between the rotor and stator. Multiple pillars between submersible buoyant structures reinforce the outer structure, making it easy to increase the size of the central submersible buoyant structure. Screen on the outer perimeter of the pillars prevent the infiltration of foreign matter. BD Energy Korea's tidal current power generators will become part of your life as a next-generation generator.
So I hope you understood the actual working, or you imagined, or you got idea about how it actually works. So now we are going to see the next type of the power generating method.
It's a third of my grade.
Your ideas are on the money. Let's make sure they come across clearly with grammar. Watch it work. Watch it work.
Whether it's alien, moon,
Here to make its place. So the next method of generation is the tidal barrage. So in this method, tidal barrage makes use of the potential energy in the difference in the height between the high and low tide. That means that there is a one type of the barrage or difficult. So in this one type of the barrage or difficult part is a created barrier is placed and so there is a difference in the height between the high tides and low tides when using the tidal barrages to generate the power. The potential energy from the tide is sized through the strategic placement. And so there is a one strategy or then one strategy is applied so that maximum amount of the potential difference is created, and depending on the potential difference, that means that at one side the sea level rises and at the another side the water level is low. So in that way the structure is made like this, and so by utilizing that potential difference the electricity is generated. So we all know the tidals or water is flowing from the high potential to the low potential. When that water is flowing from the high potential, that water is trying to create force on the turbine. So whenever that force is created on the turbine, the electricity is maximum amount of the electricity is generated through the turbine. So I will just show you one video regarding this. So I will show you one video regarding how barrage tidal power station actually works.
Here. Today I'm going to do a short video about tidal power generation. I've loaded up the model on the website. We can see it here. You can see that the ocean is on the left hand side. There is a barrage or a barrier here, stopping the ocean flowing into a bay or an estuary on the right hand side. And we use the barrage or barrier to block the sea when it's trying to come into the estuary or the bay. What I'm going to do, I'm going to push play. Now we'll see the animation in action. Notice the tide on the left now is increasing slightly. I'm going to pause it there. There is no flow or very little flow from the seaside to the right hand side or into the bay area. The reason is this wicket gate, which is the area just here. You can see it just behind this blue piece here. This is called a wicket gate. The wicket gate was closed, so there can be no flow from the sea to the bay or the estuary area. Notice that you can also close these gates here. This is called a sluice gate, and there's another sluice gate on the right, and that will completely isolate the turbine hydraulically, and that means there is also no flow. But the water level has increased here. It's at a higher level on the sea side than it is on the bay or the estuary side here. And if I push play, the wicket gate has now opened and we're getting flow. You can see the wicket gate here is just open. We're getting flow now coming across this bulb turbine. This is a cross section of a bulb turbine. It's imparting thrust upon these propeller blades here. This is what we call a control pitch propeller, and we're turning the turbine. The turbine turns the generator and we generate electricity. Now notice these blades change position so that we can generate electricity in two directions. The water level, I'll just pause it here a second, is now equal. The sea or the tide is up. It's
So in this process, what is a structure like this is created. So the maximum amount of the water barrier is created. So here two gates are applied. So the water level of the sea. So that the sea is available here. I have shown through the cursor. So here is the sea, and here bay or 4 bay is created. That means the one barrier is created here, so the water should be water level at this side should be increased. Whenever the water level at this seaside is increased, so these gates are opened. So whenever that these gates are opened, the water flowing through a higher potential to the lower potential. So whenever that water starts flowing, the turbine starts rotating, and the when that but height water level height is equal, that means the whenever a potential difference between these two water will become equal, that means the height of this water and this water will become equal, the turbine stops rotating. So this process is utilized in case of the tide barriers.
High point, so the tide's in, and the bay is full. So we can't get any more water in the bay, so the water level between the two sides is equal. There's no flow between the two sides because there's no pressure differential between the two sides. However, once the tide begins to recede on this side, we can leave the wicket gate closed until there's at least 2 meters difference in height or head of pressure between the sea and the bay area. Once we have that 2 meters, that's sufficient flow in order to drive the turbine, will impart thrust upon the blades, drive the turbine and generate electricity. Let's play the animation again. Hopefully in a minute we'll be able to see the water draining out from the seaside. Here we go, it comes down. Notice that there's no flow. Keep an eye on the wicket gate. The wicket gate is now opening because there's sufficient difference in height between the two levels. That means there's sufficient flow going to occur once we open the wicket gate. And the blades should be also adjusting position. You just see that now. Notice they're spinning around. This is because we want to impart maximum thrust onto the blades as the water's flowing across. And in order to do this, we have to be able to adjust the position of these blades. That's why they call it a control pitch propeller. When you adjust the position of the blades, you're adjusting the pitch. Again, the flow has stopped because the water level on the two sides is equal. You'll need at least 2 meters difference between the two sides in order to generate electricity. That is essentially how hydroelectric generation works. Relatively simple process. You're artificially controlling the difference in height between the two water levels in order to get a high flow from one area to another until the pressure is equal.
So just listen, some amount of the potential difference is created either from the this side left side or either from the right side. So whenever that at least a 2 meter difference is should be there in the water levels. So whenever at least for the there may be difference more than 2 meter also. So at least a 2 meter difference should be there in the water level of the sea. Whenever that difference is created, the gates are opened to flow of the water from the higher level potential to the lower level potential. When that water flows from the either from the left to right or either from the right to left. So whenever that process is going to happen, so the turbine starts rotating. So because whenever that water is flowing from the higher potential to the lower potential, some amount of the force is created. Okay, so this is the next type of the next method of the tidal power generation here.
Tides flowing in
Here is enormous.
Tidal lagoon is the
wall over
next
5
method
miles
of the
long
power
to
generation.
enclose a vast body of water into a lagoon here in Swansea Bay. Large power generating turbines will be set in the sea wall. Here's how it works. On the left here is the open sea. Its height
The
increases.
work, the working of the tidal lagoon is somewhat similar like the tidal barrage. So it is not exactly same like the tidal barrage, but somewhat similar like the tidal barrage. So you can see in the video actual working, so you can visualize how it actually works.
From low tide to high tide. The sea wall holds the rising tide out of the lagoon on the right. Then a wicket gate is opened to let the high tide flow in. That makes electricity. When the lagoon fills up, the tide goes out, and the whole process is reversed to make energy once more. We're about 1.5 miles out to sea now, and it's right down beneath the
20 years, very certainly, a little bit expensive to start.
wildlife too much. Energy from the engineers can and the power is concerned, the anglers. What about the impact of the lagoon on local rivers?
We're very worried about tidal lagoons because they have the potential to chop up lots of fish, and the positioning of lots of lagoons near the mouth of rivers is very alarming for us.
There's another drawback. The lagoon will have to be subsidised by bill payers, and it's looking very expensive. The developers claim a second they want to make at Cardiff will provide energy for about the same cost as nuclear and much more safely. Ministers are committed to getting almost all our electricity from low-carbon sources. They hope a fleet of lagoons round the coasts of Britain will prove affordable as well as reliable. Roger Harrabin, BBC News, Swansea.
Okay, the function of the lagoons, tidal lagoons, is somewhat similar like the tidal barrage. So these are the methods of the electricity generation by using the tidal powers. If anyone have query regarding this, they can ask me directly how it actually works, etc. Okay, if you speak about the advantages of the tidal energy, so advantages are shown here. So as similar in the last sessions for the ocean thermal energy, some advantages are same in case of the tidal energy also, as it is renewable source of energy. So this is one advantages. And apart from the initial cost, the fuel cost is not necessary in case of the fuel cost is not necessary in case of the tidal energy, because we are utilizing the free energy that is available in the ocean or sea for the generation of the electricity. So from this type of the energy sources, there is no greenhouse gases created or any other type of the pollution is not created by the use of this type of the power plants. That means the pollution is not, it is pollution free, or any type of the gases are not created. It requires no fuel. So so maintenance cost is not much in case of tidal energy generation. So is anyone having more idea about the advantages? Then also they can tell. So there is one more advantage in case of the high electricity generation. So we all know the electricity generation through the tidal energy is not constant. So why this is not constant? Because the tide generation, that means that there may be high tide, low tide, depending on the geographical constants. So this is depending on the force exerted by the earth. So the waves are created. So whenever there may be a high electricity generation at one time, so that electricity can be used, can be transferred to the more applications or for the more parts. If there is a low power generation, so some another type of the electricity generation source can be used in combination with that sources. So there, this is one more advantages. So if there is a low energy generation, we can use some another electricity generation source for the combination. And if there is a high electricity generation, we can share that highly electricity generated to the another source. So this is one advantage. So one last advantage is there, offshore turbines. That means there are types of the turbines, offshore turbines and vertical axis turbines are the two turbines. They are very cheap in cost and very easy to build up. So they and they don't have any environmental impact on the their construction or their working. So this is the one advantage. So this is about the advantages of the tidal energy. I hope you all understood this pointer. So in this session we will stop here itself. So in the next session we will revise these points again if you not got the idea about. So the repetition of the points will make your ideas clear. Okay, so we will stop here. Thank you for joining the session.